जय श्री राम जय श्री राम जय श्री राम सीताराम सीताराम। जय बजरंगबली, जय हनुमान जी की, जय हनुमान जी की। ओम नमः शिवाय, ओम नमः शिवाय, ओम नमः शिवाय। Now in this lecture, I would like to talk about time sharing. That is, time sharing. It is a mechanism to provide simultaneous interactive use of a computer system by many users in such a way that all users feel that he is the sole user of the system. It uses multi-programming with a special central processing unit, central processing unit scheduling algorithm to achieve this. A time-sharing system has many, even hundreds of user terminals connected to it simultaneously. Using these terminals, multiple users can work on the system simultaneously. Multi-programming feature allows multiple user programs to reside simultaneously in main memory, and a special CPU scheduling algorithm allocates a short period of CPU time one by one to each user process, from the first one to the last one, and then again beginning from the first one. The short period during which a user process gets to use central processing unit is known as a time slice, time slot, or quantum, and is typically of the order of 10 to 100 milliseconds. Hence, when the operating system allocates CPU Hence, when the operating system allocates a central processing unit to a user process, the process uses the CPU until its time slice expires. That is, system clock sends an interrupt signal to central processing unit after every time slice, or it needs to perform some IO operation, or it completes its execution during this period. Notice that the operating system takes away central processing unit from a running processor when its allocated time slice expires. The requirements of time sharing systems. Time sharing systems require following additional hardware and software, a number of user terminals so that multiple users can use the system simultaneously in interactive mode, relatively large memory to support multi-programming, job job status preservation mechanism to preserve a job's status information when the operating system takes away CPU from it, restore this information back before it gives central processing unit to the process again. Memory protection mechanism to prevent a job's instruction and data from other jobs in a multi-programming environment. A special central processing unit scheduling algorithm that allocates central processing unit for a short period one by one to each user process in a circular fashion, and an interrupt mechanism to send an interrupt signal to CPU after every time slice. Now, advantage of time sharing systems. Advantage of time sharing systems. The first advantage is reduced central processing unit idle time. Thinking and typing speed of a user is much slower than processing speed of a computer. Hence, during interactive usage of a system, while a user is engaged in thinking or typing his or her input, a time-sharing system services many other users. Time-sharing system therefore reduce central processing unit idle time and provide higher system throughput. Second point is provide advantage of quick response time. The special CPU scheduling algorithm used in time sharing system ensures quick response time to all users. This feature helps in improving programmers' efficiency by making interactive programming and debugging much simpler and quicker. Multiple programmers can work simultaneously for writing, testing, and debugging their programs, or for trying out various approaches to solve a problem. The greatest benefit of such a system is that all simultaneous users of the system can detect error, correct them, and continue with their work immediately. This is in contrast to batch system in which users have to correct errors offline and then resubmit their jobs for another run. We often measure in hours the time delay between job submission and returns of the output in batch system. The next point is offer good computing facility to small users. Small users can gain direct access to more sophisticated hardware and software than they could otherwise justify or afford. In time sharing system, they merely pay a fee for the resources they use and are relieved of hardware, software, and personal problems associated with acquiring and maintaining their own installation. Now let's talk about the memory management. Other than central processing unit, main memory is an important resource of a computer system that the operating system must manage properly for overall system performance. Memory management module of an operating system takes care of this requirement. Its job is to keep track of free and occupied parts of memory. It also allocates memory to process when they need it and deallocates when they no more need. In this situation, we will learn about different memory management schemes used in earlier and modern operating systems. So, in this lecture, let's first see the uniprogramming memory model. Many computer systems process one job only at a time, and all system resources are available exclusively for the job until it completes. Uniprogramming memory model is suitable for such systems. In this memory management schemes, operating system uses one part of the memory and its remaining part is available for use by the currently active user process. The operating system loads a program from disk into user area of memory and executes it. When the process finishes, the operating system cleans up the user area of memory and then loads the next program which is ready for execution. This memory management scheme is simple and easy to implement. It does not lead to proper utilization of main memory source. This is because the unoccupied memory space in user R remains unused for entire duration of execution of the currently active user process. Hence, very small or dedicated computer systems, only system used for a specific application only use this memory management scheme now. Now multi-programming memory models. In a multi-programming system, multiple user processes can reside simultaneously in main memory. The two memory management schemes which operating system use to facilitate this are multi-programming with fixed number of memory partition and multi-programming with variable number of memory partition. Now let's discuss this. First one is the multi-programming with fixed number of memory partition. In this scheme, the operating system divides the user area of memory into a number of fixed sized partitions. These partitions may be of same or different size, but the size of each partition is fixed. Now consider a multi-programming memory model with n equal size partitions. Each partitions may contain exactly one process. Hence, the number of partitions bounds the degree of multi-programming. That is, in a system with n memory partition, the system can load maximum n processes at a time. N is a number. The operating system queues all new jobs in an input queue. When a partition is free, it loads the next job from the input queue into that partition. When a process terminates, the partition it occupies becomes free for use by another process. Note that in a system that uses partition of different size, when a partition becomes free, the operating system loads the first process in input queue that fits in it. It is called MFT, that is multi-programming with a fixed number of tasks and is no longer in use. Now the next one is multi-programming with variable number of memory partition. In the scheme described, multi-programming with a fixed number of tasks. Since all partitions are of fixed size, any space in a partition that is in excess of actual memory requirement of process loaded into it remains unused. On the average, 50% of main memory may remain unused due to this, resulting in underutilization of memory resource. To overcome this problem, researchers introduced another scheme with variable number of memory partition. In this scheme, number, size and locations of partition may vary dynamically as processes enter and exit the system. Consider a memory management scheme. Initially, all memory in a user area is available for user process. When a process enters the system, the operating system allocates to it only as much memory as it needs, keeping the rest available for future requests. A processes enter and exist, the operating system allocates and deallocates memory partition to them. each partition being equal to the size of memory required by corresponding processes. Since memory requirements of different processes is generally different as processes enter and exit the system's memory is partitioned into various size of free memory blocks. Operating systems maintain a table to keep track of free memory blocks. When a new process arrives, the operating system searches for a free block that is large enough for this process. If the free block is too large, the operating system splits it into two parts. One part is large enough for the process, while the other part contains remaining memory from the block. The operating system allocates the former part to the process and enters the latter part as a smaller free block in the free block table. When a process terminates, it releases the partition allocated to it. The operating system enters the released partition as a free memory block in the free blocks table. However, if the released partition is adjacent to any free block, the operating system merges it with the adjacent free blocks to create a larger free blocks and update properly the associated entries in the free block table. In this manner, number, size and location of partition vary dynamically as process enters and exits the system. Now let's talk about make a brief discussion about virtual memory. Virtual memory. Conventional memory management schemes discussed until now suffer from two main limitations. First, the operating system cannot load a process and hence start its execution in a system whose main memory size is less than the total memory required by the process. Second, the operating system cannot load a process and hence start its execution until sufficient free memory for loading the entire process becomes available. This may delay a process turnaround time. Jai Shri Ram, Jai Shri Ram, Jai Shri Ram. So virtual memory is a memory management scheme to overcome these limitations by allowing execution of a process without the need to load the process in main memory completely. The process can execute even if it is loaded in main memory partially. Virtual memory mechanism uses the following three basic concepts for its realization. The first, online secondary storage. It is an online secondary storage device having much larger capacity than main memory. Usually modern computer systems use high-speed disk storage for this purpose. Next point is swapping. It is the process of transferring a block of data from online secondary storage to main memory or vice versa. When the operating system transfers data from online secondary storage to main memory, it is called swapping in of data, and when it transfers data from main memory to online secondary storage. It is called swapping out of data. Now the next point is damping paging. In a virtual memory system, the operating system partitions all processes into in a virtual memory system, the operating system partitions all processes into pages which resides on online secondary or storage. The operating system also partitions the physical memory into page frames of same size. Now, instead of loading an entire process before its execution can start, the operating system uses a swapping algorithm called demand paging. The algorithm swaps in those pages only of the process which the process currently needs in memory for its execution to continue. This idea is based on the observation that since a computer executes a program's instruction one by one, it does not need all parts of the program in memory simultaneously. When there is no free page frame in memory to accommodate a page that the operating system needs to swap to continue a process execution, it invokes a page replacement algorithm to create one for the accessed page. Page replacement deals with selecting a page that is residing in memory but is not in use currently. The operating system swaps out the selected page to free the page frame it is occupying and then swaps in the accessed page of the process in the freed page frame. So the virtual memory is often described as a hierarchy of two storage systems. One is a low cost, large capacity, low speed system on linked disk storage, and other is a high cost, a small capacity, high speed system, that is main memory. Operating system manage them in such a way that users feel that they have access to a single, large, directly addressable and fast memory. That is, from the point of view of applications, programmers effectively effective effective or virtual size of available main memory is unlimited. However, the mechanism includes some performance penalty due to swapping in of currently needed page of a process, which makes frequent inter page calls. Modern compilers and linkers arrange memory and instruction calls in a way to minimize inter-page addressing, leading to reduced paging, that is page swaps. Now let's talk about the advantage and disadvantage of virtual memory. Advantage: it provides a large virtual memory to programmers on a system having a smaller physical memory. That is, physical memory size of a system does not constrain its logical memory size. Second, it enables execution of a process on a